Hudson Bay of Manitoba, Canada, to northeastern Florida, to South Africa and Iceland, all the way to Monterey Bay, whales are found in every sea and ocean on planet Earth. Their existence begins 50 million years before ours, far before the dawn of language, civilization, and life as we know it, and is yet inextricably linked to our own. Before we begin, however, I must preface, extraction and examination of the whale brain is extremely rare. As Tom Mustell, celebrated marine biologist, writes, a good quality whale brain is gold dust. When a whale beaches, they cannot release the heat required to prevent their body from pressure cooking its own brain. Often, by the time we find a whale, it's too late. To obtain a good quality whale brain for examination, the stars have to align. Cetaceans are mammals, and just as our world begins, so does theirs. The development of the whale brain is relative to the species, and we will cover many in this video essay. But first, let us start with the sperm whale. In the 16th month gestational period, the facial cranial nerves are the first to develop. Vestibular and trigeminal soon to follow. Interestingly enough, the cerebellum and the pons are the slowest to develop. Why? Slower development allows for a finer-tuned sense of balance and coordination, which is essential for the baby whale. While the ability to swim is innate, navigation and finer skills such as jumping is not. Whales must watch their mothers very carefully, which can be difficult, especially when their mothers have to leave them behind in search of food. Even after 16 months of development, the baby whale's skull, lungs, and heart cannot endure the pressure of the ocean's depths. So when hunting for food, mothers must leave their young. Similarly to humans, raising a whale calf takes a village. Other mothers will form a close relationship with each other and guard the other's young. This phenomenon is called alloparenting and is induced by increased levels of oxytocin released into the bloodstream through the pituitary gland. The prefrontal cortex and amygdala also play big roles in this social behavior. One of the functions of the amygdala is to recognize and respond to social cues, prompting mothers to love one another's young like their own. With no father present, it is truly mommy and baby whale against the world. Until they grow up. As the whale develops, the anatomical structure of the brain only becomes more complex. In the orca, also known as the killer whale, the forebrain is especially intricate. Unlike humans, the gyri and sulci of the whale brain are extremely deep. Why? Well, some of it can be linked to time. A study on magnetic resonance imaging, or MRIs, of the cetacean brain connects the lobular and circular differences to the 50 million year time gap between the dawn of whales and humans. But why anatomically? 2 words: surface area. Larger brains allow for more complex function. Sounds pretty simple, right? Until you come to reckon with the sheer size of the whale brain. The brain of the blue whale is about 15 pounds, or about 5 times bigger than the human brain. The thalamus is massive, and the limbic lobe is striking. The sperm whale has the biggest brain on planet Earth. When you hear all this, you might ask yourself, why? Why the blue whale? Why do they need such a big brain in the first place? What does this mean for brain function? What about intelligence? Can whales feel like humans? Can they feel more? Let's begin with the wiring. For starters, the dorsal ganglion, which transmits receptors to the central nervous system, can be up to 75 feet long in blue whales. This is because the size of the blue whale requires neurons to be larger. Functionally, this can lead to delayed perception and less reaction. However, this does not negatively impact their intelligence. In fact, cetaceans are considered to be some of the most intelligent beings on planet Earth. Dolphins, orcas, sperm, and blue whales are all well-renowned for something humans cannot help but fail at every single day: communication.
Is to grow, baby, in me. I could be a good mother, and I wanna be your wife, so I hold you to my knife.
When the human speaks, the prefrontal cortex lights up. Half of the neurons are activated by phonemes, the other by syllables, some by morphemes. When we speak versus when we listen before speaking, this order may change completely. Whales don't experience this disconnect. Whistles, pulses, and clicks are the most common form of communication in the cetacean world. For thousands of miles, a single whistle can be heard, echoing through the waves. In the same way humans come to recognize one another's voices, whales come to create their own whistle and recognize each other's. Clicks, on the other hand, are more similar to the concept of echolocation, as utilized by bats. Whales use clicks to map their entire world, from hunting and swimming to finding their way back to the ones they love. New studies show that echolocation is made successful through a feedback loop in the brain, from the auditory cortex to the frontal lobe. Information flows from the frontal lobe to the auditory cortex before going back in the opposite direction to prepare the brain to receive reflected sound. While humans may forget one another's voice, whales may remember individual clicks and whistles for a lifetime, especially when it comes to the one they love. For so long, the idea of loving was understood as a concept unique to the human race. However, fossils tell a different story. Nicholas Longrich, a professor of evolutionary biology at the University of Bath, writes, "Humans and all other mammals share one kind of love, the bond between a mother and her offspring. The universality of this attachment suggests that it's the original ancestral form of bonding, the first kind of love from which all others evolved." And evolved it did. Today, we may see love in the songs that play over the radio and the way they reach out across streams just to hold one another. Whales see it in the songs they sing, the way they find each other, and the way they find us. The longest whale song is that of a sperm whale, a mating call that lasts 30 minutes and repeats for hours on end. But, you may argue, to mate is not to love. And you'd be right. Mating is innate, induced by hormones and the cycle of life. Love is different. So where's the line drawn? How do we differentiate? It all comes back to the brain. We are enabled to love and suffer emotionally through a singular type of cell, the spindle neuron. Before whales, humans and primates were thought to be the only existing animal to possess such cells and such abilities. But now we know this is not true. Sperm, humpback, orca, and belugas are all understood to understand love. And when we look to their actions, the way an orca mother cares for her young, stories of whales leading sailors through an overboard back to their boats, and even Juno, a beloved beluga at the Mystic Aquarium who often officiates human weddings, the exhibited empathy and compassion which love derives all make sense. In the animal kingdom, real love is as rare as the spindle cell it's linked to. If we had taken the time to watch, we may have seen just how much and for how long whales have been caring for not only each other, but for us. Unfortunately, humans don't always show whales the same kindness. As a species, we have become stunningly good at removing blame. Shame and guilt evolutionarily has kept us alive and kept us from killing all that lays around us. But as we steer closer and closer towards a future where such is obsolete and avoidance is the key to productivity and advancement, we write the expiration date for not only our species, but thousands of others, perhaps the entire Anthropocene. Whether you believe this or not is, sadly, based not on your view and holistic understanding of our natural world, but the political agenda you've been bred to subscribe to. And arguably, however, is a trail of damage humans plow as we speak, one which marches straight to the core of the beautiful animal we have just spent these past several minutes exploring. Let's talk about the human effect on the whale brain. The National Oceanic and Atmospheric Association lists vessel strikes and fishing gear entanglement as the greatest threat to whales. The concussions and hemorrhaging which occurs is not dissimilar to the injury in the human brain. Weakened blood vessels begin to leak before bursting, creating intense pressure between the brain and skull. During entanglement, infection often occurs, leading to sepsis. Sonar, which is comparable to a 747 jet engine to humans, between 140 to 160 decibels, is deafening for all cetaceans. In waters near Hawaii, the noises are enough to cause brain bleeds in local whales. While we are certainly not the biggest creatures in the world, we are the most powerful. The future of everything that came before us rests squarely in the actions we do and do not take. When we watch populations enter declines and endangerment and simply continue to cast that net, map cargo routes through waters which should be protected, and create networks of deadly frequency for military efficiency, we make a choice. Horrifyingly, and despite starting millions of years before the dawn of humanity, the Cetacean Odyssey will end with us. When a whale dies, the brain enters autolysis. A general lack of oxygen and nutrients begins the cycle of decomposition. Usually out of all the organs, the brain is the first to go. This is especially true when a whale beaches. While on land, the whale becomes incapable of releasing its own body heat, resulting in a steam pressure that destroys the delicate tissue of the brain. Every complex facet, overdeveloped lobe, and cable-thick nerve may be gone in an instant. A scientist has just days before the concept of preservation becomes meaningless. A whale found too late is nothing but a spectacle, unless you happen to be a whale. For 17 days and nights after the death of her newborn calf, orca mother Taliqua carried her newborn on her back across the ocean, just one of the many post-mortem behaviors observed in whales after experiencing a loss. When a whale dies alone, however, perhaps with a blood-heavy brain permanently trapped in a fishing net or at the end of its natural life, having swum away from its pod, its body simply sinks. This is called a whale fall. For the final and first time, the whale comes to rest on the ocean floor. In Manitoba, Canada, and in Monterey Bay, the cetacean brain falls silent. All songs, an echo.
Words are flowing out like endless rain into a paper cup. They slither wildly as they slip away across the universe. Pools of sorrow, waves of joy are drifting through my opened mind, possessing and caressing me.